All right, you're in the home stretch. This is the second required video for today, and this is the last thing you'll be doing. If you don't finish this before class ends, you'll need to finish it before you come to class tomorrow. So we have done absolute value equations. We did a lesson on them and we did a classwork on them. This is absolute value inequalities. If you remember, inequalities are less than, greater than, less than or equal to, greater than or equal to. We're going to look at some examples. We're going to look at a lot of examples in just a minute. Just want to show you that these are the steps to solving an absolute value inequality, and want to just highlight a couple things. First of all, you isolate the absolute value exactly like you did with equations. The thing about inequalities, and I'll show you in a minute, is that if you multiply or divide by a negative number, you gotta reverse the symbol, and that's something that you learned back in middle school. You did this in middle school. You should have anyway. So after you isolate the absolute value, determine if it can happen. If it says this absolute value, let's put an example right here. For example, if it says the absolute value of x is less than negative 10, you can't have an absolute value that's less than a negative number. This cannot happen. So if it ends up after you isolate the absolute value that it's something that can't happen, your answer is no solution. You can stop right there. So you can put no solution, or you can put that symbol there. If it can happen, then you set up two inequalities just like you did with the equations. Positive version, negative version. The negative version is a little bit different, and I'll show you what it looks like, and then you solve the inequalities, and then we're going to graph. We are also going to do, on most of ours, we are going to do interval notation also. So add that here somewhere, that I expect to also see interval notation. Okay, moving down on that page, you've got two sections. One of them looks like this, and one of them is a less than. So if you have a greater than or equal to symbol, then this is called an or statement. So greater, we think of the word or. It's an or statement. In other words, it's either or. And what your number line is going to end up looking like is you're going to have intervals that are like this. And you might remember graph and stuff like this when you were in middle school too. They're separated. They are, this might be an open circle and this closed circle, whatever, but they're on two different sides. So they're going to go in opposite directions. And then over here, if you have the less than symbol, we think of the word and. That is going to end up, you don't have to draw this if you don't want to. We're going to draw it in a minute anyway. That's going to end up with your numbers like this, and it's going to be everything in between those numbers. So if you have a less than, it's going to be between two numbers. If you have a greater than, it's going to go in opposite directions. So we think of the or. We would also use the U symbol, which stands for or too. So these are the steps. All right. Get a different color. Oh, I'm going to be using like 4 different colors on some sections of these notes, so you might want to grab some pens or some color pencils or something. I think it might help you to use different colors. So we'll highlight the absolute value like I did with the equations. This absolute value between the bars is already isolated. I don't have anything up here multiplied. I don't have anything subtracted or added here. So it's already isolated. So now what I can do is I can separate it into, I can split it into two different inequalities. The first inequality is going to look exactly like it does here. So we're just going to rewrite everything and take it out of the absolute value bars. X minus 2 is greater than or equal to 5. The the negative inequality, we're going to reverse the symbol and we're going to change this to a negative. So the only thing that changes from the equations is reversing the symbol, because you can't reverse an equals. Okay, so x minus 2 is less than or equal to negative 5. Then we'll just solve each inequality like it is and figure out what it looks like on the number line. So I'm going to add 2 on both sides. X is greater than or equal to 7. And then I'm going to add 2 over here. X is less than or equal to negative 3. All right, let's think about the number line. So because this was a greater than, I know that I'm going to have something going this way and something going this way. I already know that. I want to think about where these two numbers are on the number line though. I've got a positive 7 and I've got a negative 3. A negative 3 is going to be over here in relation to the positive 7 on the number line. I want you just to really be aware of that. Don't put these, just because the 7's over here and the negative 3's over here, don't put the 7 here and the negative 3 here on the number line. Just really be careful with that. Okay, so let's look at the negative 3. I want you to remember closed circle and open circle also, because I'm going to put a circle here. And y'all are going to think this is really silly, but I'm going to tell you how I used to teach my middle school students to know whether it was open or closed. I would tell them, look for this line right here. Pretend that that line is your marker or your crayon or whatever. So if I have a marker here, if it shows up, then I can color this in. If there's no marker, I can't color it in. So I draw my circle and then I look, okay, oh, I've got a marker, so I know that is a closed circle. I also would tell my middle school students to look at this arrow. If that arrow is pointing to the left, then that's what we color. We color everything to the left. So you can color it like this. You can just make a thick line or whatever. So I'm going to color everything to the left. So look over here at the 7. I'm going to draw my open circle, and then I'm going to look for my marker. It's there. I have a marker to draw it in because that's the equal symbol. So I'm going to color that in, and then my arrow is going to the right. So this arrow is going to go to the right. So that's everything greater than or equal to 7. Now, I also want to do interval notation for these. And it's two different intervals, and they're joined by that U symbol. You might remember that from before. So this one comes from left to right. I'm just going to go from left to right all the way through. Left to right, this comes from negative infinity. And it stops at negative 3. Negative 3 is included, so you remember that's a bracket. And then there's a break, and that's where that symbol comes in. That's the or part. There's the positive 7, that's included. And then it goes to positive infinity. And that would be parentheses, because infinity and negative infinity are always parentheses. So we have the inequalities. So I want to see where you've solved the inequality. We have the number line. And we have interval notation. So on most of these, I want to see all of it. Okay. Let's also just make a really quick note in here that greater than, and I'm going to misspell this because it's got that word or, greater than inequalities will go in opposite directions. Okay, moving on to this one. This is the less than, and we put the word, the D on the end of it so that we know that there's an and. This, if we were to just state this verbally, we would use the word and. Okay, so the absolute value is already isolated, so I'm going to rewrite it exactly like it is. And then I'm going to write it again, changing the symbol to a greater than and changing this to a negative 4. So let's look at the positive side. I'm going to subtract 5. X is less than negative 1. So that's one of the solutions. And then I'm going to subtract 5 here. X is greater than negative 9. Now think about this. Think about that number line again. We're going to do that next. And we can put the word and in here. So if you were going to state this, you'd do it in the opposite way. But anyway, it doesn't matter. You would say x is greater than negative 9 and x is less than negative 1. So let's think about where these go. Negative 9 is to the left of negative 1 on the number line, because negative 1 is greater. So what we're looking for here is we're looking for overlap. All right, so let's look at everything that's greater than negative 9. So I've got open circle here. Whoops, I'm going to do that in green. open circle. And everything that's greater than is everything going this way. So all of that is greater than -9. Everything less than -1 starts here at the -1 and goes all the way to -infinity. But what I'm looking for is I'm looking for the overlap. So I'm only looking for this part right here that's both red and green. And what I would do is I would use, if I wanted to do interval notation, I would use open circle, -9, which is parentheses, and then -1, open circle again, parentheses. So my interval goes from -9 to -1, and neither one of those is included in the interval. So what I also want to make a note of here somewhere, you can do this somewhere in that little block, is that less than inequalities graphs of the number line, they will overlap. But your solution set is just the overlap part. So everything between the two values is the solution set. So you don't really have to draw that, all of this out here and all this out here. Just think, okay, I know it's everything between the two numbers. I need to look and see if it's an open circle or a closed circle. Is the solution set. If there is no overlap, there's no solution. Okay. All right. What is the difference between an equation and inequality? This is not rocket science here. Equation has an equal sign. So it only has one equal sign. That's the only thing it can't have. Inequalities, there are 4 different symbols that they could have. Inequalities have either less than, greater than, less than or equal to, or greater than or equal to symbols. Now, let's review just really quickly. The less than and the greater than, they are parentheses. They're also open circles. I'm gonna make this a different color. I'll make this green. Less than or equal to, greater than or equal to, these are brackets, and they are closed circles. Okay, moving on down, we're going to do some examples. Our first example is this one, and we see that the absolute value has already been isolated. So when we do the positive version, we write it exactly like it looks. X minus 20 is greater than 5. When we do the negative version, we write the same thing on the left. The left side doesn't change. X minus 20, and then we switch the symbol, we reverse this symbol, and we change this 5 to a -5. Now, also, once we've isolated this, that's when we look at whether this is greater than or less than. Because we've isolated the absolute value, this is a greater than, this is going to be an or statement, so that means it's going to be going in different directions on the number line when we draw the number line. Okay, let's go ahead and solve these. Let's see, I'm going to add 20 to both sides. X is greater than 25. Add 20 to both sides again. X is less than 15. So let's see. Again, these are kind of backwards, I guess, as far as the number line is concerned. Let's draw a number line. Make sure you realize that 15 is to the left of 25. I'm going to put the 25 here, 15 over here to the left. Let's do the 15 part. Everything less than 15 is open circle, and everything this way. Everything greater than 25, open circle, everything this way. Our interval notation, going to be two different intervals. I'll do those in the same color. It's going to be negative infinity to 15, and that's parentheses because it's open circle. And then our U symbol, and then 25 to positive infinity. If we were going to state this, we would say x is less than 15 or x is greater than 25. Because if we said and, if we use the word and, we'll just put an or in there too, there would be no solution because it can't be both. It can't be less than 15 and greater than 25 at the same time. There's no number that would fit that. Okay, so example number 2, I would encourage you to pause your video and try this one and then come back and then hit play again. I'm going to go ahead and solve it. So you pause it, when you come back to it, it'll be solved. Okay, so this is what you should have gotten when you solved it. You should have gotten x is less than or equal to 7 or x is greater than or equal to negative 1. Actually, it's and, sorry. This is an and statement because it's less than. So we'll say and. So what we're looking for is the overlap, and what I did was I took the negative 1 and in blue, and I just did this above the number line so it didn't kind of clutter up the whole number line. So greater than or equal to negative 1 would be everything from here to the right, and then less than or equal to 7 would be everything from here to the left. So what I was looking for is where the red and the blue both are, and I did those in purple, because red and blue make purple. So the number line would look like this. You wouldn't need this part or this part. You would only need to show that it was everything between those two numbers, including the two numbers. And then your interval notation is just bracket. I'll do this in purple too. Bracket, negative 1, and then 7, and then another bracket. Okay, so going back to the original steps that we had, the first one was isolate the absolute value. It's isolated. The second one was determine whether it can actually happen. Well, an absolute value has to be a positive number, and everything less than 23 is a negative number. So a positive number can't be less than a negative number. So we'll just say positive cannot be less than negative. So the answer here is no solution. So we would just do that. Okay, number 4. Okay, this is called a compound inequality, and I'm going to show you how to do this without separating this into 4 different inequalities. Just bear with me, try to keep up. I'm going to use a couple different colors here. There's another way to do this, and that's separating this into 4 different inequalities, but for me, I think it's easier to do it all at one time. So here's how we'll do this. We've isolated the absolute value on the inside of these 2 symbols. I do want my symbols to always be less than. If I'm going to end up with some greater thans over here, but then I'm going to switch it all around. So just to show you, this is isolated. So we can work with it just like this. We're going to just rewrite this exactly how it is. And then I'm going to show you how to solve this. If you have a compound inequality like this, what you can do is just solve for x in the middle. So everything you do to the middle part, you also do to either side. So instead of being 2 sides, like 2 sides of an equation, it's actually 3 different sections that you have to solve. So if I subtract 1 here, I have to subtract 1 here and here. Now, if I were going to multiply or divide by a negative number, I have to switch these symbols, but I don't have to do that because I'm just subtracting negative 1. 5 minus 1 is 4. And then these cancel out. So I got x in the middle, which is what I'm aiming for. And 7 minus 1 is 6. So the first interval is going to be between the numbers 4 and 6. What this is it's 2 different intervals on the same number line, and they don't overlap or anything, but it's still possible. Okay, so the other side, we're going to take the same, the middle's going to stay the same. These 2 numbers are going to change to negative, and these 2 symbols are going to switch. So we have negative 5, and then we're going to change that to greater than x plus 1. Then we're going to change this to greater than, change this to negative 7. So, like I said, I want all my symbols to be less than. So what I need to do is flip this entire thing around. So if I do that, then I can switch these and make them less than. That way I can see where the x ends up being. So let me show you. I'm going to take this -7, put it over here. I'm going to say -7 is less than x plus 1 is less than -5. Okay, so I just wanted to switch it around. You don't have to. You can actually solve it like this, but I think it's easier to do the graph if you've done it this way. So again, I'm going to subtract 1 everywhere. I end up with x in the middle, and this is -8, and then this is -6. So this is I'm not going to worry about or and because it's a compound inequality. Let me show you what it looks like on the number line. Okay. Well, I've got these negative numbers over here. I've got 4 numbers. 1, 2, 3, 4. I need to decide where they go on the number line. -8 and -6 are to the left of these two. So -8 is the smallest number. Just need to make sure I get them in order. So my first interval is x is between -8 and -6. I've got, let's see, did I have any equal to? Let me look and make sure. No, they were both less than. So -8 is less than x, and then x is less than -6. So open circle, and it's just everything in between. So there's my first interval. I'm not going to worry about interval notation on this one either. Just want to show you what this looks like on the number line. And then this is going to be 4, and this is going to be 6. So everything's in order. I got 4 numbers, 4, 6, -8, -6. So I just need to make sure they're in order on the number line. And then this x is everything between 4 and 6, and the 4 and 6 aren't included. Open circle, and everything in between. So that's what it looks like on the number line. Again, I'm not going to worry about interval notation. We're going to do some of that on key features on Wednesday, but don't worry about that right now. So that's what that one looks like. We're going to have one more like this in a minute. Let's move on to number 5. Number 5, I need to isolate this. I'm going to add 1 to both sides. Add 1, I get absolute value of x plus 5. Not equals. Is less than, that's going to be -7. I cannot have a positive number that's less than a negative number. So if you ever end up with less than a negative number, it's no solution. We're done with that one. That's all we need right there. Number 6. Okay, so make a note here. Somewhere on your paper, make a note. In inequalities, if you multiply, and this is the hardest thing for my students to remember a lot of times, if you multiply or divide by a negative number, you have to reverse the symbol. And that's what we're going to have to do here. That's why I wanted to make sure I got this note in. So just make a note somewhere on your paper that if you do that, you have to reverse the symbol. Here I'm getting ready to divide by -2. So again, I want to get this by itself. So that means I need to divide by -2. When I divide by a negative number, I got to switch this and make it greater than. So absolute value of x plus 3 greater than -3. This is always true. All positive numbers are greater than -3. So if you end up with one like this, where anytime you've got a negative number over here, it's either going to be no solution or all real numbers. So an absolute value is always greater than -3. So this is always true. Let's just make a note. This is always true. So our solution is all real numbers. And that's the symbol for all real numbers. Okay. And if you wanted to do an interval notation, that would be our good old negative infinity to positive infinity. Okay, number 7, let's see what we've got. Okay, why don't you pause the video and try this one and then come back to it. Okay, so the absolute value, you would isolate that, and when you added, move up a little bit more. When you add 7 over here, you get 14. Hopefully that didn't fool you into putting a 0 right there, because I almost did. Okay, so then you separate it, split it into two different ones. Do less than or equal to 14, greater than or equal to negative 14. Solve for x. I got x is less than or equal to 10/3. You don't even need to know what 10/3 is. You don't need to convert that or anything. You know it's a positive number, so it's to the right of this -6, because on this side I got x is greater than or equal to -6. If x is greater than or equal to -6, there's a closed circle here. If it's less than or equal to 10/3, there's a closed circle here. And again, when we isolated this, it was a less than, so we know it's going to be in between the two numbers. Also, there's a little memory thing that I saw somewhere, less equals nest. And they kind of equated this to like a bird nest, and it was everything in between. So it nested in between the two numbers. If that helps you remember it, great. So anyway, closed circle, everything in between. Interval is brackets and these two numbers. Okay, so let's see. Here we have a couple things to do till we can isolate the absolute value. We need to subtract 8 and then divide by 7. So when I subtract 8, get that, divide by 7. Again, I didn't divide by a negative number, so I keep that greater than. Put my positive version over here. My negative. And solve for x. Okay, that looks right. This was a greater than, so it's going to be opposite directions. Two intervals going opposite directions. So let's do, on a number line, we know -5 is to the left of 1. So there's a -5 and the 1. Okay, this arrow goes to the left, closed circle, everything to the left. And this one goes to the right, closed circle again. Let me make sure I wrote that correctly. Let's see. Yep, closed circle. Okay. And then our intervals are -infinity to -5. And then we have our U symbol. And then that's ones included, positive infinity. Okay, we're almost done. I'm going to go through this one as fast as I can. We have another compound inequality. We are going to rewrite this with two inequalities. One of them looks exactly like it is here. And then the other one, we're going to switch the symbols and switch these to negatives. -5 greater than 3x minus 1 greater than or equal to -8. And then I'm going to switch this whole thing around because I want everything to be less than, because this is two intervals on the same number line. And both of them are nest intervals. Both of them are in between two numbers. So I'm going to switch this -8 greater than, or excuse me, less than or equal to 3x minus 1 less than -5. Okay, the red one. Let's add 1 to everything. And then let's divide everything by 3, which we can divide and get whole numbers. So that's going to be 2 is less than x is less than 3. That's my first interval. Okay, and then let's go over here and do this one. Let's add 1. And then I'm going to divide by 3. These don't turn out to be whole numbers, but that's okay. Okay, so now I've got one number line and 4 numbers. The hardest part is figuring out what goes where. So I got 1, 2, 3, 4 numbers. I know my blue ones are negative, so they go over here. -7/3 is less than -4/3, so I know that one goes all the way to the left. My blue interval, -7/3 closed circle, -4/3 open circle, and it's everything in between. The red one, I got 2 and 3. That's how they look on the number line. Open circle, everything in between. Number 10. Once I isolate my absolute value, I'm going to add 7. That's negative. Absolute value 4 minus 8b is less than 19. When I divide by -1, I have to switch this symbol. Remember, I told you if you have a negative number over here, look and see. If it's less than, it's no solution. If it's greater than, it's all real numbers. All right, and that is it. We will practice this some more tomorrow. And I might give you some IXLs on this. I think that would probably be good. All right, so you're done for the day. If it's still class time, then you don't have anything else to do today. I'll see you tomorrow.